Hello, everyone, and welcome back to Math Zone African Motives. So, I want us to continue with our practice questions on forces and Newton's laws. We are still on forces and Newton's laws. So, what I want us to do on this video is to go through these questions that I've brought. There are questions from past question papers. So, what I want us to actually dwell much on is on multiple choice questions. Multiple choice questions. Get to understand the reasoning behind multiple choice questions, how we get to pick up the best option from the given answers. So, without wasting time, let's actually get to dive deep into it. As a bus pulls away from the cab, the standing passengers move backwards as a result of one of Newton's laws. Which law? So here they are telling us that when this bus, you can see we have got standing passengers here. And these standing passengers, you can simply tell that they are not moving. They are stationary when the bus is stationary. Now they are saying that the bus pulls away from the cab and the standing passengers move backwards as a result of one of Newton's laws. Which law is that? So you can actually get to remember that each and every body has got that tendency to resist motion. So when the body pulls away, it will be going in that direction, or else its motion would be in that direction. So the tendency of the bodies to resist motion is what we refer to as inertia. That is the one that would actually make these passengers, when the bus pulls away, for them to be moving backwards. Why? Because initially they were at rest and there is a sudden change in motion. That sudden change in motion would actually get to suffer a resistance to change that motion due to inertia. And the law that describes inertia is what we call the law of inertia. The law of inertia, which was Newton's what? Which was Newton's first law. Newton's first law of motion, which states that each and every body will remain at its state of motion, or else at its state of constant motion, or else at its state of rest, unless a net force acts upon it. So at this instant, there is no net force because there is just a sudden change. So that sudden change will face an opposing force, which is due to inertia. So this is the reason why the passengers will move backwards. Up until this change in motion, this force that is causing the forward motion becomes greater than inertia. That's when we will now start experiencing a net resultant force, which will lead these passengers to start moving in the what? In the forward motion. So we would actually get to say that the law that governs this is the what? Is the Newton's law, is the Newton's first law of motion. Newton's first law of motion, which just states that an object will remain at its state of rest, or else an object will remain at its constant state of motion unless a net resultant force acts upon them. So here the question was, as the bus pulls away from the cab, the standing passengers move backwards as a result of one of Newton's laws. Which law is that? It is Newton's first law. Now let's go to the next. So the next question is saying, which one of the following is an example of a non-contact force? Which one of the following is an example of a non-contact force? So we now need to define what a contact force is and what a non-contact force is. so that we can be able to know which forces fall under this classification and which forces will now fall under that classification. So contact forces require physical contact. These ones, they require physical contact. They require physical contact. They need objects to actually have some physical contact. For example, a push or a pull, frictional forces, because we need the roughness of a surface, as well as the normal force, because the normal force acts perpendicular to the what? To the plane of the surface. It is due to the plane of the surface. So the normal force, the frictional force, as well as the push or a pull, they need or they require physical contact. So I can simply say that forces that fall under contact forces would be to say we have got a push or a pull, which becomes the applied force. And then we have got what? We also have got some tensional force. So the tension or else tensional force acts along a rope or a string. So this also require what? Physical contact. And then we have got the normal force. And then we have got the frictional force. These, they fall under contact forces. What about non-contact force? These, they do not require any physical contact. They act, maybe, let's get to say, they act through a distance. So they do not require what? Physical contact. So these ones do not require physical contact. But however, you would know that in between two objects which are in space or else at a distance, there is some force. There is some force. So what are these forces? We know that we have got what? The electromagnetic force. We have got the electromagnetic force. So this can be broken down into electric force. We have got magnetic force. And then we also have the gravitational force. So under non-contact forces, where we do not require physical contact, we have got electric force, magnetic force, gravitational force, and what else do we have there? What else can we have there where we do not require what? Physical contact. So you also need to actually think of which other forces act where there is no what? Where there is no physical contact. So with these classifications that we have said, we are now able to answer our question, which says, which of the following is an example of a non-contact force? So an example of a non-contact force is gravitational force. The answer was going to be B, because frictional force is a contact force. Tensional force is a contact force. Normal force is also a contact force. So our correct answer there was going to be B. So this is how you answer your multiple choice questions. Now let's go to the next question, which says a lawnmower is pushed across the ground with a force of F at an angle theta with the horizontal. The weight of the lawnmower is W, as given on this diagram. They are now saying the normal force in N on the lawnmower is. They want you to give what is equivalent to N given this scenario. So the best way to approach this is to first distinguish or else determine the exact forces acting on this lawnmower. So we have got this normal force which is going up, and this normal force has to be balanced since the lawnmower is actually not spinning or else not going up or down. It has to be balanced by some forces that are going down. And which are those forces? We have got this weight force. And then we can see that there is this applied force that is also directed downwards as well as horizontal. So we need to actually get to what? We need to actually resolve this force into its components. So how do we resolve that force? We are saying that force F, which is acting that way, we can resolve it into its vertical force, which is going down, that is Fy, and then its horizontal force that is going towards the right. So you would see that also going down, I now have Fy. And then in my horizontal, I now have what? Fx. So the forces that are acting on this lawnmower, I can actually get to use, maybe let me get to say a free body diagram to say I have got a normal force there. Let me try to draw it neatly. I've got a normal force. And then going down, I've got my weight. And then I also have got my what? My vertical component of this applied force. And then going this way, I also have got my what? My applied component force in the what? In the horizontal direction. These are the forces that are acting on my lawnmower. So now, if let's get to say this lawnmower is not going down or up, what becomes the magnitude of this normal force? So you can see that this normal force would be balanced by the forces that are going down. So the normal force would be equal to Fy plus W. So my answer was going to be W plus Fy, because I've resolved this force into its two components. And I've actually determined the forces that are acting on my object and what is actually happening on my object. So if my object is remaining stationary in terms of the vertical plane, then it means that the normal force is going to be balanced by every force that is going down. So my answer was going to be B. So that is simply how we answer our multiple choice questions. So with that, let's meet in our next coming videos.